So this is the third of three video tutorial explanations of the cost model workbook and how to navigate it. So again, we've got four sections. We've got the overarching visualization tools, dashboard, cell sensitivity analysis charts. We've got the cost model itself, the battery manufacturing and cathode, anode, electrolyte. We've got the inputs, which was on video 2. And then the fourth is the pack layers for both energy storage systems and for electric vehicles. So what I'm going to talk now about is the model itself. So it's built up from each component going into the battery, starting with the anode. So at the front page on the dashboard, I've selected synthetic graphite. And what we have here is a summary table at the top based on what's input now. Then we've got the actual process flow of synthetic graphite. Underneath synthetic graphite is natural graphite. Underneath that is a different form for silicon graphite. So let's go through synthetic first. So you've got each process step, and I'm just going to minimize this or zoom out a little bit so you can see it better. You've got each process step for synthetic graphite, starting with grinding, to purification, to extrusion, to spheronization, carbonization, graphitization, coating, and then bagging and QA testing. So 8 different steps in making synthetic graphite. Let me zoom in to make sure this is easy to see. So I'm going to go over each one of those steps and what they look like. And this is true of all of these cost model tabs. You start with some general numbers. Based on our inputs, we're trying to figure out how much graphite is produced per year. This is kilograms per year. You put in your yield. How much do you lose in this process step? In this case, it's going to be, we're saying you lose 1% of the materials going into this process step in the course of this process step. In each one of these process steps, we're saying we're going to choose the capacity utilization of the factory. In other words, it's operating at 85% of capacity, and 5% of the hours of the year it's down for maintenance or whatever reason. Then we've got the equipment. So we've listed out the equipment required in this step, the grinding step. You've got the ball mill, the mills themselves, and then you've got a separator that's filtering that out. Again, yellow boxes are input, so you can put in your own numbers for those. Then here, in this case for the synthetic graphite, you get to choose how much the proportions of materials. So very often it's 100% needle coke, but in this case we're selecting a combination of needle coke and coal tar pitch for making this synthetic graphite. So that all adds up to this equipment number. So we end up with $1 per kilogram of finished anode powder of 13 cents for the equipment used in this step. Followed by this labor costs, you end up at $16. We're putting in the actual employees needed in this step. I can say a supervisor is needed here. It will recalculate that. Same with energy. We have the energy inputs elsewhere, and we've got the energy calculations elsewhere. But it's going to end up with an energy number there. And then it's automatically collecting the bill of materials numbers. So everything at the bottom, as well as consumables. In this case, there's no consumables. But at the bottom of each process step, it summarizes this process step as part of the cost of that material. For anode and cathode, it's dollars per kilogram. For battery, it's dollars per kilowatt hour that we're looking at. So essentially we're saying that the bill of materials to make synthetic graphite costs 66 cents a kilogram. That's the needle coke and coal tar pitch mostly. The cost of manufacturing is 40 cents for this step. Cost of goods sold is cost of manufacturing plus bill of materials. So that's $1.06. So that's the basic structure of every one of these process steps, and that's true for anode, cathode, and battery manufacturing. Let me just show you the electrolyte one, which is a little bit different. So in electrolyte, we need to determine the proportions of salt to solvent to additive, and this is how you do it. So I'm saying that this is an EC-DMC solvent mixture. I'm saying it's 60% EC, 40% DMC. And again, if it's a green cell, I can choose something else. I can say that's PC, not EC. It'll automatically look up the density of the PC and make changes accordingly. Or I can say it's EC, but it's actually 50-50 with the DMC. So that's the solvent numbers and the way to calculate that. Then we go into the additives, and we have additives are a bunch of essentially pre-programmed additives that we've identified. A lot of them, but definitely not every possible additive you can think of. But at least, we're trying to capture the big ones. So I can say, in this case, they're putting 5% FeC, and usually there's some VC, often at 1%, and it'll, again, recalculate. And finally, you've got the salt. In salt, we're doing it by molarity, so usually, it can be a lot of different things, but we're just saying it's all LiPF6, and it's 1 mole of LiPF6. These are all very standard additives. Maybe not the FeC unless it's a silicon anode, but these are all, the way it's programmed now, it's standard, but you can play with it and change things. Then we do have the same process stage cost model for the making the electrolyte, and you can play around with that, but right now it's pre-programmed with our numbers, and you end up with, when you do all these, one of the things that it'll do when you do all of these inputs is it'll figure out how many grams per kilogram of electrolyte come from the